All right, so then today we will be talking about adding these with like denominators. Okay? So when we think about adding fractions, how can we add them? What's the only time when we can add two fractions together? If they have the same denominator, right? So if they have the same denominator, we can add them together. And then how do we add fractions with the same denominator together? So like if we have 2/5 plus 2/5. Yeah, 4/5. You keep the denominator the same and you just add the two numerators together. Okay? So today all the denominators are the same. So if all the denominators are the same, that just means you need to add or subtract your numerators, whatever the sign says. So for the first one, we have 2a or 3a over 5 plus 2a over 5. So the denominators are the same. So when we add our two numerators together, 3a plus 2a, what does that give you? 5a, not over 10, over 5. The denominator stays the same. Ooh, that. You then want to look and decide whether or not you can do any simplifying. So can we simplify? Yeah, 5 over 5, what will that simplify down to? 1, so this just becomes a. Okay, so we combine them together, and then it becomes a simplifying problem, which we've been doing. Okay, so number 2. No, you never add the bottom. You always keep the denominators the same. So number 2, x squared plus 3 all over x minus 2 minus 10x minus 7 all over x minus 2. Well, we know it's all over x minus 2 because the denominators are the same. So we have to keep in mind here that we are subtracting. So we'll definitely have x squared. And then to get the order right, we want to put the x's next. So what would we put next? Yep, minus 10x. And then we have a 3 minus a negative 7. Minus a negative 7 is a plus 10. Now, you may want to, if you see the minus sign, some of you may want to change that to add the opposite throughout so that you do not make errors. Okay, now I just circled this one right away. Why do we know that this is for sure the answer and that we can't simplify anything? Yeah, well, this is, you're right, it's not multiplication, but x squared minus 10x plus 10, you can't factor that. It's not going to factor down. So then this would be simplified. You could get a quadratic here that would be factorable, and maybe one of the factors is the same as x minus 2. But we know here it definitely isn't because x squared minus 10x plus 10, 10, your factors of 10 are 10 and 1 and 5 and 2. Those aren't going to give you an outside-inside of negative 10. Let's look at these two. Number 3, 4p minus 3 all over p plus 2 plus 5 minus 3p over p plus 2. So what do we know the denominator is for sure? Okay, we got the denominator, p plus 2. Numerator, we are adding, so we need to combine the like terms. So 4p, what are we going to add to that? To the minus 3p, so what's 4p plus a negative 3p? P. 4 minus 3 is 1. Negative 3 plus 5, what does that give you? 2? So we get p plus 2. Yeah, so this equals 1. P plus 2 over p plus 2, those are the same, so those would cancel. So the solution would just be 1. Is that one okay? Okay. Let's look at the next one. 5x squared minus 3x plus 2 all over 2x minus 1 minus 3x squared plus 3x minus 2 all over 2x minus 1. So denominators are the same. So what do we know the denominator is? 2x minus 1. What operation are we doing in between right now? We're subtracting. So perhaps we should change the opposite throughout so that we don't make some sign errors. Okay? So now we want to get our like terms together. So we have 5x squared and a negative 3x squared. What will that give you? 2x squared. Minus 3x and another negative 3x. Negative 6x. 2 and a plus 2. Plus 4. Okay, do you think that our numerator might factor to one of the factors of 2x minus 1? Yeah. I mean, it could. So here's what you can do to try. So the only way how this could be simplified is if one of the factors is 2x minus 1, right? So what you're going to do to check to see if this can simplify is you're going to make one factor 2x minus 1. Okay, if this is 2x minus 1, what does our other factor have to be? What does our first term have to be? X. And our last term would have to be minus 4. So now let's check. The outside, 2 times negative 4, is negative 8x. And the inside is minus x. Does that give us a negative 6x? No. So that means it's not going to factor down to give us anything simplified. So that's our final answer. This turned out to be x minus 4 because your first terms had to give you a 2x squared. So if this was 2x, that had to be x. Your last terms had to give you a positive 4. So if this was negative 1, that had to be negative 4. And then you just check to see if it works. If it doesn't work, then you know you already had the simplified answer. If it does work, then you could go one step further. Does that make sense? Number 5. 4y squared plus 2y minus 3 all over 5y plus 1 minus 3y squared minus 2y minus 4 all over 5y plus 1. So what's the denominator have to be? Okay, 5y plus 1. So numerator, combine our like terms. So this is a minus in between. So what should we probably do? Yeah, change the opposite throughout. Okay, so what do we end up getting here? Okay, so we get a 1y squared, 2y plus 2y, 4y, and negative 3 plus 4 plus 1. Is there any way how y squared plus 4y plus 1 could factor and one of the factors be 5y plus 1? No. It's not going to happen because here your first term is 1. So our first term would have to be y and y. There's no way our first term would be 5y. So that's our simplified answer. Does that make sense? Number 6, 3m minus 3 over m squared plus 3m minus 4 plus m minus 7 over m squared plus 3m minus 4. Okay, so what's our denominator have to be? Yep, m squared plus 3m minus 4. Numerator we're adding, so we just want to combine our like terms. So 3m plus m, 4m, negative 3 plus negative 7, minus 10. Would we be able to get a factor from m squared plus 3m minus 4 that could cancel with a 4m minus 10? No. Even if we took a GCF of a 2 out, our first term is still a 2m, and that's not going to ever come to the square. So is that okay? All right, let's do one more. We'll do go to combine the numerators, we want to make sure we combine all the like terms on the numerators. Alright, so we see that we are subtracting both of these last two fractions. So what should we probably do with those signs? Probably change them. So plus a negative 5, a positive 2x, and a positive 6. And then plus a positive 14x squared, a positive 4x, and a negative 2. And now we go through and we'll just combine all of our like terms together. So we have 3x squared plus a negative 5x squared plus a 14x squared. Yep, 12x squared. Okay, now combine our x's. 4x plus 2x plus 4x. 10x. And negative 12 plus 6 plus a negative 2. Negative 8. Okay, so there we combined. So now what do we need to check? Yeah, we need to check to see if this would factor to either a 3x plus 4 or an x minus 1. So let's first see if this factors with 3x plus 4. So we're going to make the first factor 3x plus 4. If this is 3x, what is our first term? That's got to be a 4x. And if this is 4, what does the other last term have to be? It's got to be a negative 2. Let's see, here the outside term would be negative 6x. What would our inside term be? 16x, 4 times 4 is 16, right? Yeah. Negative 6x plus 16x, what does that give you? 10x. Oh, so does that factor? It does factor to this. So instead of 12x squared plus 10x minus 8, that's the same thing as 3x plus 4 times 4x minus 2 all over our denominator of 3x plus 4 times x minus 1. So since that factors, what can we cancel? 3x plus 4's we can cancel. So then we're left with just a 4x minus 2 over x minus 1. Is that okay? Does it make sense why we are only trying to see if it factors down to one of these two? Because if it factors down to anything else, we won't be able to cancel it, so it wouldn't be simplified.